So let's look at the table of observed counts for people's views on Wall Street executives and self-identified social class. So this is our contingency table of counts. You can see that I've included here the marginal totals. So you can see the number of people who identify as lower, middle, and upper class. And you can see the number of people who think Wall Street executives are dishonest, meaning yes, they do think Wall Street executives are dishonest, versus no, those people who think Wall Street executives are in fact not dishonest. So overall, we can see the sample size is 810. You can see 537 people in our data think that Wall Street executives are dishonest. 273 people think no, they're not dishonest. And then we can see that most people identify as middle class, so 471 people. 183 people identify as upper class, and 156 people identify as lower class. What we want to know is, this is a random sample from the population. Right? Maybe we just got a weird sample, just an outlying sample. So we want to know, in the population, is this evidence that there's a relationship between social class and people's views of Wall Street executives? So let's conduct a chi-square two-way test for independence just to make sure. So since we're conducting a two-way chi-square test for independence, we have the following hypotheses. The null is that in the population, people's views of Wall Street executives and social class, they are unrelated. They're independent. These two categorical variables are not related. The alternative is that in the population, people's views of Wall Street executives and their social class are in fact related. They are dependent. By convention, we're going to set alpha to 0.05. So using statistical software, you can calculate it by hand, we obtain the following results. The chi-square test statistic, it's simply all these differences between the expected and observed counts squared divided by the expected counts, and you do that for each cell. We can see that the chi-square test statistic is roughly 16. The degrees of freedom is 2. That alters the shape or governs the shape of the chi-square distribution model. And the p-value, it's almost 0. It's a very low p-value. What this tells us is that we have evidence to reject the null at the alpha 0.05 level. Right? We reject the null that social class and people's views of Wall Street executives are independent. We reject that claim. Right? And of course, I also give you information about the other details of this table. You can visualize the p-value from the chi-square test because the p-value is simply an area under the chi-square distribution model. It's that area to the right or equal to our chi-square test statistic. And you can see that when we visualize it, you can see how far off, how far to the right that chi-square test statistic really lies. And the p-value is the probability of obtaining a chi-square value greater than or equal to the one we've obtained. It's almost 0. You can just round down to 0. So the p-value is very low. So if the p is low, the null must go, as we've talked about before. So we reject the null that these two variables are independent. We say that we reject the null hypothesis that there's independence in the population between social class and perceptions of Wall Street executives. And this suggests that these two categorical variables are in fact related in the population. And if you look at the pattern in the data, it suggests that there's a class difference where people in the upper class are less likely to think Wall Street executives are dishonest. Those people who identify as being part of the lower class or middle class, they're more likely to think that Wall Street executives are dishonest. So at this point, we can conclude and talk about two kinds of chi-square tests. Right? There's a chi-square one-way goodness of fit test. This answers the question, does an observed frequency distribution fit some claimed distribution? For the chi-square one-way goodness of fit test, it's one way. You're dealing with one categorical variable. For the chi-square two-way test for independence, you're answering the question, are two categorical variables related to each other in the population? That is, are these two variables dependent or independent of each other? So for the chi-square two-way test for independence, it's two-way. You're dealing with two categorical variables. For both of these, we're using a random sample of data from a population to make inferences about a population. As well, in both of these instances, the fundamental mechanics is based on the idea that we have some expected and some observed counts, right? From a contingency table or just a single table for one categorical variable. The more inconsistent our expected and observed counts, the greater the chi-square test statistic, and the more inconsistent our data is with the null hypothesis, suggesting that we should reject the null hypothesis, whether that null hypothesis entails some fit or some conforming to some claimed distribution, or whether that null hypothesis refers to independence of two variables in the population. Let's look at another example. So let's look at Wall Street and social class. So previous studies have shown that people's values and beliefs, they really do differ by social class. Social class can be measured in many different ways, using people's education, income, or typically their occupation. That's a key part of social class. You could also measure it through subjective report, ask people what social class they're part of. So what we're going to do is we're going to say, well, suppose we're an economist, and this economist wants to see if there's a relationship in the population between people's viewing or perspectives on Wall Street executives and people's self-identified social class. Sort of a common theme, the idea being that if you identify with a particular social class, which reflects your economic and occupational and educational circumstances, that might be related to your values and beliefs about Wall Street executives. So you gather a random sample of the US population and you ask them if they think Wall Street executives are dishonest or not. Now this is a real set of data. This is a set of data of US adults. We can say it's a random sample of 810 people. And we have all these questions about what Americans think of Wall Street executives. So there are a couple things to know for this part of this week's lecture. The two-way Chisquare test for independence, it's used to determine if the rows and columns of a contingency table are independent or dependent. Contingency table of counts. So it's appropriate when the data have been gathered from a random sample from a population. And it is very similar, in fact, to the Chisquare one-way goodness of fit test, but the expected cell counts and the degrees of freedom are calculated in a slightly different way to reflect the fact that this is really a test of independence. That's the null hypothesis. And the fact that degrees of freedom entails both the rows and columns. And with that, we conclude part 2 for this week's lecture.